Okay, y'all, so it's been a while since we've done notes this way. We're going to knock out two sections real quick. We're going to start our probability units, so you should be looking at notes 13.1, sample spaces and probability. So we are going to find theoretical probabilities, experimental probabilities, and we're going to use area, which we've been doing a lot of lately, to find probabilities. This right here, the theoretical and experimental, should bring back a little bit from junior high, the little bit of probability that you did then. So, theoretical probabilities is the number of favorable outcomes over the total number of outcomes. Your definition is a measure of the likelihood or chance that the event will occur. So some things will be just as likely as unlikely as to happen. We're going to note the probability of event A is going to be written as P of A. So the probability of event A. All right, so a student taking a quiz randomly guesses the answers to 4 true or false questions. The table below shows the sample space. Let C represent the correct answer. Let I represent the incorrect answer. The possible outcomes are, well, it's possible that they guessed all 4 wrong, or they could have done any of these other scenarios. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 possible ways that test could have been answered. So what is the probability of the student guessing exactly 2 correct answers? Well, there's 16 possible ways because remember it's possible, it's total outcomes, which there are 16, but favorable is we want exactly 2 correct answers. So I see that there are 2 here, 2 here, 2 here, 2 here, 2 here, 2 here. That's exactly 2. So 1, 2, 3, 4, 5, 6. So 6 out of 16, which does reduce to 3/8, which becomes 0.375 or 37.5%. So there's about a 37.5% chance of the student making a 50 by simply guessing. Now, what is the probability of guessing all the correct answers? Well, there's 16 possible outcomes. So how many choices does he have to choose from where they're all correct? There's only one. There's only one way to get correct answers. So that would be 0.0625 or 6.25%. So about a 6% chance of guessing all the correct answers, which means there's about a 94% chance that you won't. All right. Now, we're going to talk about the probability of the complement. The complement, remember, is what finishes off an event. So, for example, I just did that here. I said, you know, you have a 6% chance of guessing the right and about a 94% chance of not. So, the complement is when they both add to 1. So, the complement is noted with a line over the A, so it's 1 minus the probability of the event. So you spin a spinner with numbers 1 through 5 on it. Find the probability of getting a 4. Well, how many 4s are there? There's only 1 out of 5 4s. So that would be 0.2 or 20%. So what's the probability of not getting a 4? Well, there's 4 numbers that are not 4 out of the 5, which is 0.8 or 80%. Another way to look at it would have been to do 1 minus the 1/5, which would have been your 4/5. Find the probability of getting a number less than 3. Well, there are 2 numbers out of the 5 that are less than 3. So that would be about 40%. Find the probability of getting a number not less than 3. So that would be 3 out of 5, which would be your 60%. Or 1 minus 2/5, which would be your 3/5. All right, now let's talk about geometric probability. Geometric probability is Probabilities found by calculating a ratio of two lengths, two areas, or two volumes. So you throw a dart at the dartboard. Your dart is equally likely to hit any point inside the square board. What is the probability that your dart lands in the smallest triangle here? So what I want to do is think about, okay, I want to land in the smallest triangle. So the smallest triangle, but it's possible that I land on the board. So it's possible that I land on the square board. So I need to find the area of both. Well, I see that the radius is 4, therefore my diameter is 8. So if my radius is 4, the diameter is 8. Well, if the diameter is 8, this is a diameter, and it goes all the way across, making the side of the square 8. So the square is 8 squared, or 64. Now, if you'll recall, to find the area of a triangle, we have several formulas. You can do your base times height divided by 2. You can do some of the others that we did, which was Heron's formula, which was the S times S minus A. Or we could do the 1/2 AB sine C, which means we need side angle side. So that's the one I'm going to use because that's going to be the least amount of work for me. So I'm going to work smart and not hard. So this is 4, which means this side's also 4. So what I'm going to do is, I know this angle's 30, therefore this angle has to be 30. So 30 plus 30 is 60. So 180 minus 60 is 120. So that means this angle up here is 120 degrees. Clearly not drawn to scale. But I know side angle side now, so I can find the area of my triangle because it's going to be 1/2 side A times side B sine of angle C. So when I type that into the calculator, I get that the area of the triangle is 6.9. So I'm going to go over here and write, okay, 1/2 4 sine 120. So we get 6.9. And when I do the calculation, I get that it's about 0.108 or 10.8%. So you almost have an 11% chance of throwing your dart and landing in that small area. What is the probability your dart does not land anywhere in the circle? So I don't want to land anywhere in the circle. So first thing I need to do, I'm going to find the area of the circle. So the area of the circle is pi r, which is 4 squared, so 16 pi. The area of the square, which we already said was 8 squared, or 64. So I need to find out the area I want to know does not land. Okay, so if I'm not going to land anywhere in the circle, that means I can land in all of the corners. So to find the area of the corners, so the area of the corners is the square minus the circle. So the square minus the circle is about 13.7. So if I don't want to land in the circle, that means I want to land in the corners. So that means the probability is 13.7 over, I can still land anywhere though, which is 0.214 or 21.4%. So you got about a 21% chance of landing in the corners, which is slightly higher than landing in the small triangle. All right, what if we change our board up now? Now we have a circle board instead of a square board. And now we want to land in the square. What is the probability that your dart lands inside the square? So I need to find the area of the circle and I need to find the area of the square. Well, the area of the circle is pi r squared, and if my diameter is 12, then my radius is 6. So that would be 6 squared, so 36 pi. Just leaving it as pi because it's easy to type in the calculator that way. Now, if you'll remember when we were doing area of rhombus, remember we talked about that the area of a square, you could also do diagonal 1 times diagonal 2 divided by 2, because since a square is a rhombus, it can use the same formula. Well, if this diagonal is 12, then isn't this diagonal 12? So 12 times 12 divided by 2. So the area is 72. So the area of the square is 72. So the question says, what is the probability that your dart will land in the square? Well, the probability of landing in the square is 72, but the probability that I land anywhere is 36 pi. So make sure you put parentheses around that if you type that in the calculator that way, or else the calculator will divide by 36, then turn around and multiply by pi. So you get 72 divided by parentheses 36 pi parentheses, and you get 0.6366. So that is about 63.7%. So you got about a 63.7% chance of landing in the square. All right, now experimental is when you actually go through and do an experiment and you calculate how many times things are happening. So we want to sell some pizza at a school dance. So the first thing we need to do with our table is we need to calculate totals. So we have 42 pepperoni slices and 48 cheese slices. We have 70 thin crust and 20 thick crust, leaving us with 90 pieces of pizza. So we want to know, what is the probability that a student chooses a thin crust pepperoni? Thin crust pepperoni is 34. So there are 34 out of 90 slices. So that is about a 37.8% chance that this kid will randomly select a randomly select a pepperoni thin crust. Now, what about this one? What's the probability that a student does not choose thick crust plain? So does not. So he's not going to choose these 12. Well, there's 90 to choose from. He's not going to choose those 12. So that means he has 78 slices to choose from. So that means 78 out of 90, which is about 86.7%. All right. Now we have a spinner. The spinner has 5 sections. There's 5 different colors. They're equally spaced, same area. So we're going to spin the spinner 50 times. We've recorded our data, so there are 50 spins. What is the experimental probability of stopping on each color? Well, for red, it was 5 out of 50. Well, 5 out of 50 reduces to 1 out of 10, which is 10%. Green, well, green is 20 out of 50, so that would be 40%. Blue is 3 out of 50, which is 6%. Not very often did it land on blue. Yellow is 10 out of 50, which is 20%. And purple is 12 out of 50, which is 24%. What is the theoretical probability of stopping on each color? So in theory, if I spin it, it could land on red 1 out of 5 times. If I spin it once, I have a 1 in 5 chance. Well, that is also the same for green, blue, yellow, and purple. They all have the same probability of 1 out of 5 times because there's 1 of each color. So for the color, for which color is the experiment and the theory the same? So theory and experiment. Well, 1 out of 5 is 20%. So what was the only other color that got 20%? So yellow has the experimental and theoretical probability that equaled the same in this experiment. It could be different for another experiment. You could do your own and it could come out to be completely different. All right, so what we need to do is you need to go to the next page, which is 13.2, independent and dependent events, and we will do those.